Hi everyone, this is the gas walkthrough for July 11th. I'm Philip Newman. Today I'm solving Nonodoku by Bill Murphy. This is a nonogram Sudoku, sort of. There apparently was a Nonodoku of some sort by Richard Stolk, I believe Bill said, on Logic Master Germany. This is a slightly different rule set, apparently. It's not too complicated though, and hopefully you can see why Bill named it this. We have normal Sudoku rules, 1 to 9 each row, column, and 3 by 3 box. That felt a little weird, highlighting those cells, because we've got a bunch of stuff outside the grid that's making this grid look way smaller. And these are the Nonodoku clues, as Bill has called them. They are a string of numbers that must appear reading top to bottom or left to right without interruptions. So we need to place 4872 somewhere in 4 consecutive cells. They can't be broken up by something that is currently blank. They can't be broken up by a given digit. They just must appear in 4 consecutive cells. And that's it. Those are the rules. This one is fairly straightforward to get going on. Bill has been very kind to us. The reason this is related to nonograms, which is where the title is coming from, nonograms usually give you numbered clues that tell you how many consecutive cells must be shaded. So a 4 would say there are 4 shaded cells in a row somewhere in this column. Bill is doing that, but just giving you the digits that go in those cells rather than shading. So that's where the name is coming from. Let's start with this one. We need 4872. We can't start here because there's a 4 here. And there's a 1 preventing us from using any of these cells. So this must just be 487. So this must just be 4, 8, 7, and 2 in that order. Now the 7, 8, 6, 4 here can't start with 7 here, so this must be 7, 8, 6, 4, like that. 1, 5, 4, 6 is going to work similarly. We can't start it here because 3 is in the way. And we can't do these 4 cells because it ends in 6, and there's a 6 already in that column. So this is 1, 5, 4, 6 like that. And then 1853 here, again, these are dead to us because of the 4 here. We can't have a 3 in the cell because we've given 3. And so this is 1853, like that. That's all of our outside clues. Alright, let's look at the other clues. Remember where we want to start with them. Let's look at this the 6394, and this ends with 4, and it can't be here. So there's a 4 in one of these cells, which means there's a 9 in one of these cells, which means there's a 3 in one of these cells, 6 in one of these cells. There's a 6 in this row though, so it can't start here. It must start here. And we know it can't be any farther out because we have these 4s. So a 4 here wouldn't work because of that 4. What about this 6195? So this row can't have 9 or 5. So it can't end here. It also can't end here. And we couldn't start with 6 anyway. 6 needs to go up here somewhere. So we could have 6195 like that. That's fine. 6195 like that. Seems to be fine. 6195 like this does not work because of this. So it looks like we have a couple options for now. Let's look at the 2748 though. So now that we have the 9 here blocking this off, we know it must go here, here, or here. So 2748 works. This can't be 2 because of that 2. And this can't be 2 because it would put 7, 4, and that breaks there. So this is 2, 7, 4, 8, like that. And now that's going to restrict, actually it's not going to restrict our 6195 at all. That's okay. Let's look at the 2165 then. So it can't be here because of the 6. 2165 seems fine here. But as soon as we get to here, we start to break because this is 2, 1, and there's a 1 here. And there's a 2 here as well. So none of these can be 2 or 1, and we run out of room here. So this must be 2165 like that. That means this can't be 6. Or 1, for that matter. So where do we put our 1 here? We can't start there with 6. It's one of these. And if we start here, we get a 1 here. So this must be like this. And I feel like I explained all of that kind of poorly. I'm a little tired. I feel like I've been talking more today than normal. But let's show those clues, how they're resolved. And at this point, it's just a classic Sudoku. So let's see what we can find. We need 3, 5, 9 here. 3, 5 in the column. 3, 5 pair here. These are 2, 6, 7. There's a 2 there. And there's a 6 in this row already. These are 3 and 5 in that order. These are 2 and 7 in that order. 5, 7, 9 here. 1, 6, 8. It's got to go here. 1 and 6 there. These are 1, 3, and 6. Neither of these can be 6. So 1, 3 pair here. This is a 9. These are 1, 3, 5. 1 and 3 here means this is the 5, and there's a 1 up here. This is also 5. 4 and 2 in this box. 3 here. 4, 8, and 9 there. These are 2, 3, 7. We have a 2 in the box here. 3, 7. 1, 8, 9. We get the 8 here. So 1, 9 paired there. This is 3 and 7. 6, 8, 9 here. We still need 2, 4, and 5 in this row. We have 4 and 2. And we have a 2, not 2, 4, 5. 2, 5, 7. Okay, so that's not 2, that's not 2, that is. And we have a 7 here, so 5 and 7 go like that. This is 5, 9, and that's going to resolve our 1, 9. 3, 7, 8 here, gives us an 8. 3 and 7. 1, 4, 6 here is resolved by our 1s and 4. 6, 8, 9. I'm losing my voice. Almost there though. 4, 8, and 9. That's the solution. Really cool puzzle. Not too hard on the variant. You could make this a lot harder. But this is gas, so we keep it approachable. But I really enjoyed solving that one. I feel like I solved it better in testing than I did on the video. That happens sometimes. But anyway, I hope you enjoyed it as well. Let us know how you did in the comments. I will see you next time.